So today's lesson is talking about solving quadratic equations. And there's actually 5 different ways that we're going to learn how to do. We're going to focus on the first 3 today, just because you've probably seen them already or you're used to doing the methods that is involved. So today we're going to cover solving by graphing, solving by using the square roots, and solving by factoring. So when you're solving by graphing, basically we're going to use a graphing calculator. We can sketch it by hand, but you cause a lot of room for error in that case. So we're going to use our graphing calculator or the Desmos website. And we'll go over in class how to use that Desmos site in a little bit more detail. But what we're looking for are the x-intercepts. We're looking to see where does the graph cross the x-axis, if at all. And in red on the bottom, it's just important to know that when they say solve a quadratic, they may also ask you a couple different things. They might say find the roots of the system or the equation. They may say find the zeros of the function or find the intercepts, the x-intercepts. They all mean solve for your variable. Okay, so no matter what they call it, solutions, roots, zeros, intercepts, it all means doing the same thing. So there's going to be a few different visuals that we're looking for. 2 ordered pairs, that's where you're going to see the U shape cross it in 2 different places, probably one on the downswing and one on the upswing. And that's where your x-axis is going to be intercepted twice. It's going to be one on each side of your vertex. You're going to see 1 ordered pair solution. That's where the graph sits on the x-axis, and that usually is your vertex. So if your vertex sits on your x-axis, if you have an ordered pair of an x comma a 0, that means your vertex sits on the x-axis. That is your 1 single ordered pair solution for that quadratic. Or you might not have any real solutions. And that's where the graph doesn't cross the x-axis at all. In that case, you will have an imaginary solution, meaning your answer is going to have an I, which is what we just looked at in the previous section. So we can no longer just take a look at a graph, see that it crosses nowhere, and move along. We're going to learn, well, how do we deal with that? How do we find those imaginary solutions? And the answer is you can't do it by graphing. You have to do it in one of the other methods. So graphing, really, we're only going to use it if we already have the graph involved. So if we look at this example, I used the Desmos, I typed it in, the equation must equal 0, and then you can type it into your Desmos or your graphing calculator, the non-zero side, and then you'll look visually, well, where does it fall? In this case, it crosses over here at -2, so -2, 0, and in this case, 3, 0. And again, we'll go through those extra practice problems and we'll really look at, well, how do we use Desmos for graphing? Now, the main ways we're going to do it for solving is by the square root method, factoring, and the other 2, which we'll focus on individually, will be completing the square and the quadratic formula. Quadratic formula can be used to solve any and every single quadratic. We're going to use that last because it is a little bit time consuming. We can use all of these other methods though. Solving by using square roots, that is only if you have a single variable in your equation, meaning you might have an x squared and nothing else, or you should have an x squared and nothing else. You shouldn't have a single x term. You might have 2 x squareds in the problem, but as you simplify, you might end up combining things, still only being 1 x squared in it. All right, so I have 2 examples here. This first one, again, I see I only have the 1 single x squared. I'm going to solve like I solve every single equation you've ever solved before in your life. You get the variable by itself. So I add 31, I divide by 4, and now I'm left with this x squared. So the new thing is, well, how do we get rid of an x squared? Well, to undo a square, you square root it. A square and a square root cancel each other out. And then you're left with plus or minus the square root of 20, which would then be simplified to plus or minus 2 times the square root of 5. So you always want to simplify your radicals first and foremost. And it's very, very important that you put a plus or minus in front of any square root you physically take. So when you're solving, if you are physically putting the square root in to solve, you must put plus or minus. because remember, the positive number squared is going to be a positive number, and so is a negative number squared. So if I had a positive 2, 2 squared is 4, and a negative 2 is also going to yield me a positive 4. So we need to make sure we put plus or minuses. Now, the one on the right-hand side, again, I only have a single term, I only have a single variable, and the whole thing is squared over here. Single variable, I can still solve by square roots. Please do not write it twice and FOIL it. You'll learn how to solve that way, but it's going to make your life so much harder when the square root method is going to be so simple. So the goal is we want to get this whole grouping by itself. So anything that's not part of the grouping goes away. So in this case, I divide by 4. And just like we did previously, I want to get rid of the square root. Well, if the whole thing is to the second power, I'm going to square root the whole thing. The 2 power, the square power, and the square root will go away and the whole inside drops out. Okay, so you're not physically putting the square to both of them. You're not square rooting both of them. You're squaring the whole grouping, causing it to cancel, leaving you with what's inside. And then I have this square root of negative 5 over 4. Well, I've kind of put to the side here. You square root the top, you square root the bottom. So the square root of negative 5 is I square root of 5, right? I could simplify by taking the negative 1 out. That becomes the I. And then 5 has to stay inside the root. And then the square root of 4 is 2. That is now what that equaled. But the problem is x is still not alone. So in order to get x alone, I just need to add 4. Well, when I add 4 to both sides, it is now a complex number. I have 4 plus or minus this radical over here, I square root of 5 over 2. That's my answer. I'm not going to try and simplify it. I can't simplify it because of the I. So I'm just going to leave it as this little expression with the plus or minus there. Okay. We have some examples that we'll go through and you guys can practice on your own. And the last method we're going to talk about is by factoring. So we spent a good part of the beginning of the school year practicing factoring. That's what your summer packet was about, because factoring is oh so important in Algebra 2. You're going to be factoring a lot. So if we can factor a problem, that's going to be a really easy way to solve it, because we have this zero product property. Zero product property means that if the whole thing equals 0, then each part can equal 0. So therefore, once we factor it, I can set each individual factor equal to 0 and solve each one individually. And again, it's very important, just like with graphing, you always need one side to be 0 before I can factor anything. So in the first one, it's already set equal to 0. I simply factored it. Factors of 8 that add to 6 are 2 and 4. And then I individually set each group equal to 0, and I have my 2 solutions. In the one on the right, it started out by giving me in a function notation. So I'm just going to replace that as 0. I want to find the roots of that function. So 0 equals that. And this was a little bit longer to factor. I have to use the grouping and the diamond method. So you multiply the first and the last. 2 times 12, that gets me 24. So I want to figure out factors of 24 that are going to add to the middle term of a negative 11. Well, that's a negative 8 and a negative 3. So in order to solve by grouping, drop the first and the last, split the middle into what we just came up with. So that negative 11 becomes negative 8x and negative 3x. And then I group it. First 2 have a 2x in common. Second 2 have a negative 3 in common. I get my factors of x minus 4 and 2x minus 3. And then set each individual part to 0 and solve it again. Okay, so that's how we would solve by factoring. Every single part that is a factor, you always set equal to 0 and solve it, and those would be my solutions. Okay, again, there's more examples. We'll go through them. We'll talk about them in class, but you have this video to keep referring to and the notes. Any questions, you know to ask me.